Hey guys, so today we're going to talk about projectile motion. We had just finished up Newton's laws, basic forces. We'll get back to some forces in a bit, but we need to touch on a topic, like I said, called projectile motion. So let's get into it. Before we get too deep into the topic, I have some opening thoughts for you guys, and I want you to kind of think about, may answer on your notes page. Again, don't forget that you can pause the video to see slides, maybe get the answers that you missed if I go too fast. But to start, I have some questions for y'all. What is the difference between free fall and a projectile? You should know the word projectile to an extent already, but think for a minute. Write your own thoughts, what the difference is between free fall and a projectile. And also now think another little deeper question. Which would take longer? Throwing a ball straight up and catching it, or throwing a ball across the room, same height, and catching it? By same height, I mean as the one you threw straight up. So think about that for a minute. Jot down your answers, jot down your thoughts. We're going to get into the actual answers in a bit, but these are just your opinion, just to kind of see where you're at to start. All right, then pause the video if you need an extra minute or two. But moving on. A projectile, the definition of a projectile. A projectile is an object in motion that is only affected by gravity. Think for a minute. That was the definition of free fall, only being affected by gravity. Free fall and projectile motion are the same thing. They're the same thing. They're the same thing. And that's why we're going to go through this PowerPoint pretty quickly. There's only a few little differences as far as calculating. For example, a couple of vocabulary differences. We drew a lot of arcs for free fall, which was really projectiles. But now we're going to give that arc a name. The trajectory, which is the path that a projectile takes, is known as a parabola. Okay, so that arc has a special name and special properties to it. It is a parabola. So the path a projectile takes is called a parabola. The range of a projectile is the total distance it travels before reaching the ground. So distance, can you identify range in the picture? So take a look. If we wanted to identify range in our picture, I don't want that there. Okay. If we want to identify range in our picture, where are we going to find the range? We're going to find the range right here. It is our x distance, right? So, come on, silly pen. I don't know why it's doing that. The range, like I said, is our x on the x-axis. So range, now it's different from what you probably learned in math. It's different probably from what you learned on math. Math often talks about range being on the y-axis, but here in physics, range is on the x-axis. Okay, sorry. Range is the total distance traveled along the x-axis. It equals xf, final position. Okay. The range of a projectile, backwards, moving on. So in class, we like to do a demonstration. And this demonstration is pretty simple. It's pretty straightforward. It is throwing a ball straight up in the air and throwing a ball across the room at the same height. Both things are at the same height. They almost touch the ceiling. And we measure the time that it takes to do that. And we find that, after we do that, we go the same height. we find that the time it takes to go straight up and across the room is actually the same. It's actually the same. And that's due to a couple of things, which we're going to talk about. For example, like I said, so trips take the same amount of time. The time for the ball to slow down as it rises and speed up as it falls is the same for both. Uh, think about it. What affects the ball? Free fall and projectile motion are the same thing. It's when they're affected only by gravity. And since both are only being affected by gravity, they go up and down in the same amount of time. The height is what influences the time. How high you threw it influences how long it's in the air. Okay? If you throw a ball 2 feet in the air, it does not matter if you throw that ball across the room 10 yards. It doesn't matter if you throw it 100 yards. It'll take the exact same amount of time to go 2 feet in the air, up and down. That's it. No, that's it. That's all. Height is your big influencer. And here's why. So here's a graph of motion of a projectile every single second. So each dot is 1 second. And what you notice on the x-axis is that they're equally distributed. X velocity, and so now pause for a moment. We're going to get into the most complicated part of projectile motion. The most complicated part is that we're dealing with two different velocities. There's a velocity on the x-axis, and there's a velocity on the y-axis, and they are different numbers. They're different numbers. They are not necessarily connected either. Because x velocity, the velocity going horizontally, so range, if you think about it, range is a distance, how quickly it travels that distance. Well, x velocity is constant. Okay, so if you throw a ball across the room, and you could figure out how quickly it's going just horizontally, not overall. So overall that's a third velocity. It's a difference, a combination of x and y. We're not going to get into that. Two velocities, x, y. So if you can measure that x velocity, it will be constant going across the room. And now look at the y velocity. Think about free fall problems. Up and down is your free fall problem. Okay? Y velocity changes. It slows down as you go up. See those lines get closer and closer together? And it speeds up as it comes down. You throw a ball up in the air, it slows down on the way up and speeds up on the way down. Okay, so y velocity changes. So calculating x velocity is actually going to be the easier of the two because it's constant. And because projectiles move differently in the x and y directions, there are two separate sets of equations. One set for the x-axis and one set for the y-axis. So you're going to have to pay attention. This is why this particular type of problem is hard, is because there's two sets of equations. They are tied together through one particular variable, and that is time. And we're going to get to that. So simplifying the equations, so we're going to kind of skip past a lot of this because it's a little more complicated than it needs to be. But because acceleration is constant, and not constant in that it's zero, there is no acceleration, it stays the same. Your x-axis equations look like this. X equals vx0 times time, and vx equals vx0. We're going to talk about these little letters here in just a minute, about what the 0 and the little x's are. When we talk about the y-axis equations, they look like this. Y equals vy0 times time times t minus 1/2 gt squared. And vy equals vy0 minus gt. Now, let me tell you what this. These equations, this is all new stuff. This is all new. These other equations over here, first look, you say, oh, I don't know those equations. Well, look, let me write an equation for you. X equals x0 plus v0t plus 1/2 at squared. Look at that equation. Free fall, right? Now look at this equation. See the similarity? G is gravity. A, that's also acceleration, and it could be gravity. These are the same equation. They just got rid of this part. It's the same equation. Just like this other y-axis equation, that's that v equals VO plus AT. But now notice they did the minus. Here's where it really gets confusing. Because they put in a minus here, and I don't always like that they put the minus there. What they're saying is, if you leave gravity as positive, if you leave it as 9.8, just 9.8, then you subtract. Personally, I've always told people gravity is negative, at which point you have to change this to addition. So if you leave gravity as negative, you got to do the addition, just like in the original x equation there. But if you make it positive, then you can do the subtraction listed in the original equation there. Okay. We're going to practice a little bit. Or practice this a little bit. A bullet is shot from a gun with an initial x velocity of 60 meters per second. How far does the bullet travel on the x-axis after 3 seconds? What is the bullet's x velocity after 3 seconds? We'll go through this one at a time. So how far does the bullet travel on the x-axis after 3 seconds? Well, initial x velocity. So let's get into this little Vx0 thing here. So V0 we said was initial velocity. Vx0 is initial x velocity. It's on the x-axis, okay? Because we have to distinguish between x and y-axis. So initial x velocity is 60, and the time is 3 seconds. X, if we go back into our equations, it says x equals Vxo times t. Well, x is position. And in fact, I'm going to give this equation a name. I like to say that this is range. I got a new stylus pen. It's not really writing real well. It's not my handwriting, but it's range. So range, how far does something go for a projectile? If you're ever looking for range, use that boy, okay? Looking for how far something goes. How far? Well, again, that is range. How far it goes. Range, well, we pull out the range equation. Vxo times t. Initial x velocity is 60. 3 seconds. 60 times 3. 180 meters. Okay? Range is that simple. As long as you know the time. If you know the time, boom, simple. What's the bullet's x velocity after 3 seconds? Okay, that's dealing with this other equation. Velocity after 3 seconds. Look at this phrasing. X velocity, that's what Vx means. X velocity equals the initial x velocity. So what that's saying is that x velocity is constant, because we brought that up here. Remember? X velocity is constant, which means if you know the x velocity, if you know the initial x velocity, you know the initial x velocity all the time. You know it the whole time. So if you know it at the beginning is 60, the whole time it's going to be 60. You can say after 3 seconds, after 45 seconds, after 5 days. As long as it's still in the air, it's going to be 60. Notice I said as long as it's in the air. That's where things get real tricky. So how long something is in the air does not depend on the x-axis. It depends on height. height is tied to the y-axis. Much more complicated. So splitting the motion into two sets of equations creates a lot of subscripts. We talked about that a little bit already. Y or x tells you which axis we're dealing with. Are we dealing with the x-axis or are we dealing with the y-axis? For example, Vy is the object's velocity in the y direction. So we had already covered Vx0 and Vx. Well, the same thing is true over here. That you've got Vy0, the initial y velocity, and Vy. The subscript 0 tells you the quantity is starting at time 0, which is the same thing as initial. It's the beginning. So, think real quick. Tell me, what does Vx0 mean? Refresh. Okay. Initial sideways velocity in the x direction. Velocity stays constant. Vx0, velocity on the x-axis initially. So now, here's the big kicker. What variable is the only variable in the x-axis and the y-axis? Take a look. Time. Motion in the x and y directions happens at the same time, simultaneously. Simultaneously, yes. Happens at the exact same moment. And so when we get into, sorry, I had a brain fart for a moment. So it happens at the same time, and so therefore time is our connector. Time is our connector between these two sets of equations. We need to, if you want to know how long something is in the air, you're going to be dealing with the y-axis. Knowing how long it's in the air is the key to finding the time for finding the range. So if you want to know range, you first have to figure out how long it's in the air, which is the y-axis, which is why they're tied together. Here's an example problem. Projectile is fired horizontally off the top of a cliff with an initial velocity of 30 meters per second. It hits the ground 2 seconds later. What is the initial velocity in the x and y direction? Let's take a look. Remember, previously I've said I like to list everything that's being given to me. So we got 2 seconds and 30 seconds are our numbers. So t, so our total time is 2 seconds, right? Now 30 meters per second, that's a velocity, right? But is it x or is it y? It's a key here with these problems. How do we figure that out? First, you could look at the picture. Second, look at the words. Horizontally, this way. Think about it. If you're shooting something this way, is that the x or the y axis? It's the x axis, which means this is our Vx0. Now, another question for you. Based on that, we know Vy0, the initial y velocity. So if you're going pushing it this way, x-axis, think about it. Is there any initial y velocity? Please don't say negative 9.8. Please don't say negative 9.8. That's acceleration. The answer is no. The initial x velocity is 30 because all the force is going horizontally. None of the force is going vertically. That's how you can find initial x and initial y velocity. This is something you're going to have to do in all of these types of projectile motion problems. Find the initial x and y. 30 and 0, like I said. Next question, how far from the base of the cliff does the projectile land? So thinking about what variable are you being asked for? If we're asking how far from the base of the cliff that it lands, is that the X or the y-axis. The x-axis, we're looking for range. Looking for range. What was our range equation? Range, x equals vx0 times t. Do we know the time? Sure. We said time is 2. Do we know the initial x velocity? Well, we did it in the last problem, didn't we? There it is. 30 meters per second. Plug it in. 30 times 2. Done. 60 meters. Easy peasy. It only really gets tricky to find range when you don't know the time and you have to deal with the y-axis. How high is the cliff? Are we looking for range still? We're looking for height. Height is which axis? It's the y-axis. We hadn't talked about this much before. Looking at this equation, so I gave this one was range, right? This is my range, right? It's y-axis equation though. Y, that is position on the y-axis, up and down, which means you can use it, you would use it anytime you need to find height. We're looking for y, okay? Which equals vy0 times t minus gt, or sorry, 1/2 gt squared. Initial y velocity is 0. We came up with that previously. Our time, it tells you how long it's in the air. 2 seconds. Do we know g? Now remember, if we're using the subtraction, g is just 9.8. There you go. We have all of our variables. We plug it in. You get 0 times t. What's 0 times 2? 0. So really you're just left with negative 1/2 9.8 times 2 squared. 2 squared is 4. 4 times 1/2 times 9.8. Negative 19.6 meters. But think about it. We're asking for the height. How high something is. Do you ever say it's negative? No, you don't. So we leave it positive. 19.6 meters high. It says the projectile is fired such, that's fancy, that Vx0 and Vy0 is 20 meters per second. What is the range of the projectile? Uh-oh. Didn't give you the time. What have I been saying throughout this whole presentation about finding the range if you don't have time? You have to deal with the y-axis. You got to find the time it's in the air as a whole. Okay? So, we have to go back to a free fall problem. First, figuring out how long it's in the air is a free fall problem. Keep in mind, here's how I like to solve this. Keep in mind that the time it takes to go up is equal to the time it takes to come down. So if you can figure out the time it takes to go up, then total time equals your time to the top times 2. That's it. That's kind of nice. So let's find our time it takes to get to the top using one of our brand new but yet really old equations. The time it takes to get to the top. Remember, we know some important facts. We know this Vy, Vy0 is 20 meters per second. So we know up and down, Vy0 is 20. What's the velocity at the top? If I want to find the time it takes to get to the top, then I need the velocity at the top. Velocity up and down. Think back to free fall. What is it? 3, 2, 1, 0. So our Vy at the top is 0. That's important. We can use that other equation of Vy equals Vy0, Vy0 minus GT. Okay. So Vy is 0 equals Vy0 of 20. My pen's messing up, so I'm not going to write the units. Minus 9.8 times t. How do we do this first? So first we need to get this by itself, so we'll subtract 20. Okay, so you end up with negative 20 equals negative 9.8 times t. You divide by 9.8. So your time in the air. Okay. It's your time in the air. Now the time in the air, and hold off on that number there, but your time in the air should be 2.04 seconds. If you do 20 divided by may give you a much more complicated way of doing that problem. Anyways, so you could use the y-axis equation. You could do that. But anyways, so you do 20 divided by 9.8, which is 2.04. So the time up and down is 2.04. Remember, it's double. The whole thing is double. So your total time is, in fact, 4.08 seconds. Because 2.04 times 2 is 4.08. But is that the range? No, we got to use the range equation. Range equation was x equals Vx0 times t. Well, Vx0 we said was 20 because it said it was both. Both of them were 20 times 4.08 seconds. Now it's simple math. 20 times 4.08, boom, 1.6 meters or 82 meters is your range. Okay, so that's a complicated projectile motion problem. We needed lots of those. Now, knowing the time it takes to get to the top, we could also have figured out how high it went using this equation here and plugging in our time it took to get to the top of 2.04, right? So if we wanted to figure out how high it went, we could. And I'm going to leave you with a couple of problems, which is not an example of projectile motion. Soccer ball being kicked in the air, parabola. Car traveling down a hill, rock thrown off a cliff, parabola. Package dropped from a plane. Believe it or not, if you're in a plane and you're flying, you drop something, believe it or not, as you drop it, it's still going to make a parabolic arc. It's still going to fall in a parabola. So of course, it's the car traveling down the hill, right? Now, here's your big brain buster. And I might post a video, especially for my kids. I might see if the other physics teachers will do this. Otherwise, look it up. Mythbusters, bullet drop versus bullet fired. Okay. A boy on top of a roof has two balls. He throws one sideways at the same instant that he drops the second. Which ball hits the ground first? Which ball hits the ground first? Believe it or not, remember I said height. If you fire a gun and drop a bullet at the same height, they should hit the ground at the same time. So, height is all that matters. So, believe it or not, shoot a gun and drop a bullet at the same time. They should hit the ground at the same time. And that's what I'm going to leave you with today, guys. And Mr. Peritano, this has been projectile motion.